right, let's take a look at what we refer to as the standard normal distribution. The standard normal distribution is a normal distribution like the other distributions we've talked about, but the scale along the x-axis has been transformed, and we will also transform all of the values within our data distribution. Again, it's a normal distribution that's been transformed, which means we've rescaled the distribution from its original units to what we call standard units. The most common transformed distribution is the z-distribution that's based upon z-scores or z-values. Z-scores, z-values, we're talking about the same thing. Like I said, it's usually referred to as a z-distribution, this transformed, standardized distribution that's based upon z-scores. The z-distribution has a mean of 0 and a standard deviation of 1, always, depending on what. It doesn't matter what our original units were. It could be millions of dollars, or it could be feet and inches, it could be temperature, whatever our original units were. Once they're transformed into the z-distribution, we will always have a mean of 0 and a standard deviation of 1. And this process is used with any normally distributed continuous variable. It's widely used. It is the go-to distribution for many analytical problems. Here is a look at a standard normal distribution that is based on the mortgage data that we've been talking about. Here are the original units from the mortgage data that we've talked about in other videos. The $675 value is the equivalent of a -3 standard deviation on this standardized scale. $900, the equivalent of 2 standard deviations below the mean. $1,125 is the equivalent of 1 standard deviation below the mean. The mean of $1,350 is 0 on the standardized scale. And then on the right side of the distribution, the right side of the mean, we have all of our values above the mean, and our standard deviation values are positive. 1,575, 1 standard deviation above the mean. 1,800, 2 standard deviations, and 2025 is 3 standard deviations above the mean. Like I've said before, you can do this with any data that is normally distributed. Z-scores are used with standard normal distributions, or the z-distribution that we're talking about. Z-scores are raw scores that have been transformed using the formula below. Here's the formula. Like I've also mentioned before, the z-distribution is a normal distribution. It's bell-shaped, it's symmetrical, it's asymptotic. All of the characteristics of a normal distribution with original units, all of those characteristics are found with the standardized distribution. Mean of 0, standard deviation of 1.0. Talk a little bit about the formula. Z sub x, and I won't always use the x subscript, but I'm laying it out here so you will have a better understanding of how it relates to the original units. Z sub x is the standard score value for a value of x that's measured in its original units. X, the individual score that's being transformed in original units. Mu is the population mean of the distribution in original units. And sigma is the population standard deviation measured in the original units. Again, we're using all original units here, but when we go through this process, we're going to end up with a z-score that is the equivalent of the score in original units. Let's use this formula to calculate the z-score for $943.50, and we're using the mortgage data that we used in previous videos. Start with your formula. Plug in your x value, 943.50, the mean of the distribution, 1350, standard deviation of the distribution, 225. The next iteration, we subtract 1350 from 943.50. We end up with negative 406.50. In the denominator, all we're doing is plugging in our standard deviation of 225. Last step is we divide negative 406.50 by 225, and we end up with a z-score of negative 1.81. Again, z-scores can be negative if the original value is below the mean of the distribution. They'll be positive if the original value is above the mean of the original distribution. So don't freak out when you see the negative sign. That's fine. That's just telling you that you're below the mean of the distribution. And here is the location of this z-score in our standard normal distribution. Negative 1.81, which again is the equivalent of 943.50. Once we have this location on the graph of a standard normal distribution, then we can calculate various probabilities from this location. What is the probability of randomly selecting a mortgage with a monthly payment greater than $943.50? Let's think about that problem. To answer that problem, we're going to find the area values associated with a z-score of 1.81, and only think about the absolute value here. It's going to be below the mean because it's negative, but in the z table that we're going to look at, that's presented in terms of the absolute value of our z-score. This table that I'm referring to is found in your textbook. It's table B.3, and it's on page 530. And once we have our z-score, we use this table to find areas under the normal curve. Then once we know those areas under the normal curve, we can use that information and think in terms of probabilities. Let's go ahead and talk about using this z-table. And this table is in the back of your textbook, page 530. It's a little bit different than what I've got. I'm using one that works a little bit better in PowerPoint on the slide, but it's the equivalent formula, or it's the equivalent table. To use a z-table, assuming we have a z-score, we find the first two digits of the z-score in this left-hand column. This left-hand column, this is going to be the first two digits of your z-score. The last digit of your z-score is going to be found in the top row. Your z-score should always be rounded to 2 decimal places because that is the way the z-table is formatted. The z-table is not designed to deal with more than 3 digits, 2 decimal places. And also I should mention your z-score is never going to be above 3.09. That's the maximum z-score that you can work with if you're using a z-table to find areas and probabilities. The point where the row and column intersect, we have a row that we're going to select and we have a column that we're going to select. The point where the row and the column values intersect, that's going to be the area associated with a particular z-score. But let's try to make that a little more concrete. Let's find the z-score of 1.13. Finding the z-score of 1.13. The first thing we're going to do using this left-hand column is find the first two digits of that 1.13. Find 1.1 in the left column, and there it is. That's going to identify the row that we're working on. Next, we want to find the third digit in the top row. That third digit, 1.13, or third digit is 3. So we're going to use 0.03 to find the z-score value, or the area value associated with the z-score. So, and this identifies the column that we're using. We have a column, we have a row. Now, where that column and row intersect, that is the area that we're working with. That's the area that's associated with a z-score of 1.13, 0.3708. I want to talk a little bit more about this idea of area. I really haven't explained it yet, but when we're using the z-table and z-scores in the standard normal distribution, when we talk about area, we're talking about probabilities, or a space on the normal curve that can be used to find a probability that we're interested in. Area is equal to probability for our purposes. The area probability values in the table only represent the area between the z-score value and the mean. They only represent 1/2 of the normal distribution, or the standard normal distribution, I should say. Negative numbers are going to be below the mean. Negative z-scores are below the mean. Positive z-scores are going to be above the mean. So let's move on and look at our problem that we alluded to earlier in this video. What is the probability of randomly selecting a mortgage with a monthly payment greater than $943.50? We already calculated our z-score. Again, negative 1.81 is the equivalent of $943.50. We've already located it, located the position of this z-score along our x-axis. So let's go ahead and find the area between this location and the mean. That's what we're going to be finding here, is the area between the green dotted line and the line representing the mean. Okay, find the first two digits in the left column, 1.8. Then find the third digit along the top row, 0.01. There's our area that we're working with right there, 0.4649. The shaded area is about 46.5% of the area to the left of the mean, or below the mean. So to answer our question, we'll take this 0.4649 and add it to the area on the other side of the mean. And the area on the other side of the mean is 0.5. It's symmetrical. We have 0.5 above the mean, 0.5 below the mean. So we take 0.5, add that to the area between the mean and the location of the negative 1.81 z-score, and the probability of randomly selecting a mortgage with a monthly payment greater than $943.50 is 0.9649, or about 96.5% chance that if we randomly select one mortgage out of all the mortgages in Oklahoma, it's going to be greater than $943.50. All right, that's a quick introduction to the standard normal distribution, z-scores, how to use the z-table, and also a quick example of using all of those tools to find a probability. We'll do several more examples and 4 or 5 other videos just to get you your reps, get you comfortable with using this procedure.